Hello, welcome again to my math tutorial number 25, dated 20th June 2025. My name is Mr. Lovok Cesare Rorengo. Today's topic is vectors 2, part 4. In the previous parts 1, 2, 3, and 4, I talked about vectors in 3 dimensions, both unit and column vectors, position vectors in 3 dimensions, addition of vectors in 3 dimensions, multiplication of vectors by scalars in 3 dimensions, internal division of a line, external division of a line, and also we talked about ratio theorem. And in the previous lesson, we talked about application of vectors to geometry, improving certain geometrical properties. In this session, I'm going to take you through 2 sample questions from this topic worth 10 marks. Welcome. Example 1. In the figure below, OP is vector B, OR is vector R. OS is twice vector R, and OQ is 3 over 2 vector P. The values written in black are some interpretations after the solution, but blue is the equation. Express the following vectors in terms of P and R, QR and PS. When we come to the diagram, we are told that OS is twice R. Therefore, if R is 1, from here to here is 2. Therefore, it means this is 1, this is 1, this is the same as this one. Now, we also thought that OQ is 3 over 2P. OQ is 3 over 2P. It means OQ is 3 parts, but OP is 2 parts. Therefore, here it is 2, here it's 1, to make them 3 in total. Now, vector QR, for us to get QR, we move from Q to O to R. Q to O is negative 3 over 2P, and O to R is vector R. Then vector PS, to move from P to S, we take PO plus OS. PO is negative P, and OS is vector 2R. Now, part B, given that QK equals to MQR and PK equals to NPS, express OK in 2 different ways, and hence find the values of the scalars M and N. Now, in that case, we have to use the 2 vectors given here. One way we must move around QK, another way we must move around PK. Now, from O to K through QK, we have to move OQ plus QK. That is OK equals to OQ plus QK. OQ is 3 over 2P, and QK we now use MQR, the one which has been given in this equation. But QR is already obtained in part A. That we just substitute here. So that 3 over 2P plus M, negative 3 over 2P plus R. Open the bracket, we get 3 over 2P plus negative 3 over 2MP plus MR. The vector P is common. There we have 3 minus 3 over 2 M vector P plus MR. That's one way of expressing OM. Okay. Secondly, OK can be given as OP then PK. We have OP then PK. P plus NPS. NPS has been given as PK in the equation. Therefore, we substitute. PS was already obtained here. Negative P plus 2R. We have P minus NP plus 2R. P is common. 1 minus NP plus 2 NR. This is the second way of expressing vector OK. Now the two are the same. We now compare their coefficients. For vector P, we have here 3 over 2 minus 3 over 2M equals to 1 minus N, which is here. Now, we multiply both sides by 2. When we multiply both sides by 2, we are going to get, when we multiply these both sides by 2, when we multiply both sides by 2, to remove the denominator, we get 3 minus 3M equals to 2 minus 2N. Now, take into N here, minus 3M equals to 2 minus 3, which gives us negative 1. That is one of the equations. Then, secondly, we equate the coefficient of vector R. M should be the same as 2N. M equals to 2N. That's the second equation. Now, for the equations involving M and N, we have to solve them simultaneously. Now, using the second equation, the first equation, where there is M, I will put 2N. So that I am 2N, that I'm having here, 2N minus 3 into 2N equals negative 1. Therefore, open the bracket, 2n minus 6n equals to -1. Negative 4n equals to -1. N would be -1 all over -4, which is a quarter. Now, that implies that m will be 2 vector n, the value of n, 2 times a quarter, which gives us a half. Now, part C, the question was saying, state the ratios QK ratio QR, PS ratio SK. Now, in this case, we have Roman 1, QK ratio, we use the vector QK equals to MQR. So QK is half of QR. Therefore, it means Q to K is 1 unit, then Q to R is 2 units. Therefore, the ratio is 1 to 2. Now, the second part, PK equals to NPS, and N has been printed as a quarter. Therefore, it means PS ratio SK equals to, now for this case, PK is 1 unit, but PS is 4 units. Now, to get PSSK, we come here. PS is 4 units, SK is 3 units, but in the opposite direction of the ratio is 4 to -3. Example 2. In the diagram below, the coordinates of A and B are 1, 6 and 15, 6 respectively. Point N is on OB, that 3 or N equals to 2 OB. OA is produced to L such that OL equals 3 OA. This is the figure. The one in bracket has been solved. Determine the vector Ln. Now, vector Ln will be given by the coordinates of n minus coordinates of L. Therefore, in the question, we have worked out vector Ln will be LO plus ON. Ln will be LO plus ON. Now, working on vector LO is -3 OA, which is -3 into 1 of 6, which is -3, 18. Because this one is 3 OA, now getting down is now 3 OA. Now, also, vector 3ON equals to 2 OB. 3ON equals to 2 OB. That means that ON will be 2 all over 3 of OB, which is 2 all over 3 of 15, 6, which is 10, 4. Therefore, Ln equals to LO, which is -3, -18, plus ON, which is 10, 4, which gives us 7, -14. Now, in the second part, we've been told in question B, given that a point M is on Ln such that Mn is 3 to 4. Find the coordinates of M. Mn is 3 to 4. Now, Mn equals 3 to 4, and therefore OM would be, using the ratio theorem, 4 over 7 OL plus 3 over 7 ON. That's the ratio theorem. That is 4 over 7 of 318 plus 3 over 7, 10, 4, which gives us this value. When simplified, it gives us 6, 12. Now, therefore, the coordinates of M are 6, 12. Part C, if OM is produced to T such that OM, MT is 6 to 1, Roman 1, find the position vector of T. Show that the points R, T, and B are coordinate. Now, in this question, we get to OM, MT 6 to 1. Therefore, it means OT will be 7 all over 6 OM, because OT will be now the sum of the 2 all over 6. Now, that one gives us 7, 14. That's the position vector of OM, which was obtained. Now, to show that they are parallel, we go for LT. Vector LT will be the coordinates of T minus coordinates of L, which is 4, -4. LB is this one minus this one, which is 12 negative 12. Now these are two vectors from this line. Dividing LB by LT, we get for the x coordinate we get 3, for the y coordinate we get 3. This means that LB is 3 LT and L is a common point. Hence, we can say LT and B are collinear.